a lot of people have been very interested in the history of AI. What happened before ChatGPT disrupted our lives? I'm joking. No, I'm not. AI has basically been around for about 75 years. I mean, I've read some books where they argue earlier than that, but for consensus sake and just to make things simple, it's been around for about 75 years. And often, what nobody really talks about is how every single generation has basically reinvented what artificial intelligence even means. We can't agree on a definition because we keep changing our minds about what intelligence in and of itself is in the first place. So, if you want to understand where this technology is actually going, and what it means for how we work, learn, and think, you need to understand where it came from, because this is history, right? It's not just about computers. It's about us, what we value, what we're afraid of. Come on, and what we think makes us human, right? If you're new here, I'm Shay. I'm a PhD candidate at Harvard, and this is Critical Thinking in the Age of AI. Okay, so let's start in 1950. Alan Turing, you might have heard of him before. He was a mathematician, and he publishes this paper called Computing Machinery and Intelligence. And he opens with what might be probably one of the most important questions of the 20th century. Can machines think? Now, Turing knew this was an impossible question to answer directly. Like, what does think even mean? We can barely define it for humans, right? So instead, he proposes something practical, a test. And you've probably heard of it, the Turing test, right? Or he called it the imitation game. You might have even seen the movie by the same name. And here's how it works. You're having a conversation through text with two entities. One's a human and one's machine. If you can't tell which is which, the machine passes. As simple as that. But here's what's, philosophically fascinating. I know I'm going to promise to try not to rant. This really actually connects to my episode on the appearance of intelligence. So if you want to go deeper on this, actually just listen to that episode. I'm not going to reiterate it here, but Turing wasn't really asking, can machines think? He was asking, can machines perform thinking well enough that the distinction doesn't actually matter, right? It's not about what's happening inside the machine. It's about we humans, like what we are perceiving. And as we'll see, really, the distinction becomes absolutely critical, right? So actually, let's keep going. So fast forward to 1956, there's this summer workshop at Dartmouth College, and a group of researchers get together and officially coin the term artificial intelligence. And in their proposal, they write that they believe they can make significant advances in getting machines to use language, solve problems, form concepts, and essentially improve themselves. And they thought they could all, do all of this in one single summer, biting off more than you can chew. Look, it was the 1950s, right? But that optimism actually tells us something important. These weren't just scientists building tools. They saw themselves as sort of visionaries who believed human intelligence was basically a really complicated algorithm, right? So figure out the right rules and you could replicate it. And in some cases, maybe even exceed it. That's how they, saw themselves, and this was sort of the symbolic AI era. Intelligence, they thought, is about manipulating symbols according to rules, right? If you can play chess, solve algebra, prove theorems, you're intelligent, right? So they built systems that did exactly that. And for a while, it kind of worked. They created programs that could solve algebra problems, play checkers, prove mathematical theorems. The media coverage at that time was look at what they're doing. And people really predicted we'd have human level AI by the 1970s, maybe the 80s. But once again, the definition of what exactly AI is kept changing, right? And obviously that didn't happen. So what went wrong, right? Reality kind of came swinging, right? So by the early 1970s, it became clear that the problems were way harder than anyone thought, right? Like, sure, like, AI could solve neat, well-defined puzzles. But the real world is actually kind of messy if you haven't, looked around. It's quite ambiguous. It's full of context, and common sense and things that humans just know without being explicitly taught, if that makes sense. So how do you teach a machine, for example, that a hot stove is dangerous, that a joke is funny, that this sentence is sarcastic, right? These researchers realized they'd been working on what we now call like toy problems, like clean, controlled environments that had almost nothing to do with actual intelligence, right? So eventually, like, the funding dried up, and this became known as the first, quote, like, AI winter. And it's called a winter for a reason. It was cold, dark, like most of academia. I'm joking. And people genuinely wondered if the whole field was basically like a dead end. But here's where it gets really interesting, like from a historical perspective. While AI researchers were struggling in their labs, something else was happening in the world of data and prediction. So there was this company called the Simulmatics Corporation. And if you haven't read Professor Jill Lepore's book, If Then, you absolutely should. I'm not biased, clearly. It's incredible. One of my, favorite professors in my department. And the Simulmatics was basically trying to like predict human behavior using early computer models back in the 1960s. And they were collecting data on people and building predictive models to essentially influence elections, consumer behavior, even military strategy in Vietnam, and kind of sounds familiar, right? Because this is basically like Cambridge Analytica before Cambridge Analytica existed. It's sort of like a prehistory of, really surveillance capitalism, right? But here's what Jill Lepore shows us. The dream of AI has always been tangled up with the dream of prediction and control, right? It's not just about building intelligent machines. It's about building machines that can influence. It's about building machines that can predict what we'll do, maybe even before we know we're going to do it, right? So the AI winter sort of like thawed a bit in the 1980s with something called like expert systems. So basically it was like sophisticated if-then programs that captured human expertise in specific domains. So think like medical diagnoses, financial analysis, like that kind of thing. And there was like another wave of like hype, investment promises, things of that sort. And then another winter in the late 80s / like early 90s. Expert systems were actually really expensive. They were like very brittle, very hard to maintain, and they couldn't really learn or adapt. They were basically like frozen snapshots, of human knowledge, and that's not how intelligence like actually works, right? So essentially, like here's the pattern I think you need to see. Every generation builds AI in their own image. Right. So like we take whatever we currently think intelligence is, logical reasoning, expert knowledge, like whatever, and we try to program that. And every time we're disappointed when it doesn't like transcend our limitations. Right. So we keep thinking if we can just formalize intelligence, turn it into rules and algorithms, we can reproduce it, maybe even perfect it. Right. But look, like intelligence keeps slipping through our fingers, and it's always more than what we thought it was. Like, we constantly struggle to define what intelligence is for humans. So how much more so like machines, right? Does that make sense? Okay, so now let's get to a really huge shift that I think basically like changes everything. Because I know you're wondering like, all right, Shay, like, why do we have ChatGPT? I'm rolling. Come on. Let me do my historian thing. In the 1990s and 2000s, researchers started asking a fundamentally different question, right? So instead of trying to like program intelligence from the top down, like giving machines explicit rules, they said, what if we could get machines to learn from the bottom up? What if we showed them examples and let them figure out the patterns themselves, right? Well, welcome to the world of machine learning. And it's basically based on a completely different philosophy. So instead of saying, here are the rules of chess, now play, you say, here are a million chess games, figure out what good moves actually look like, right? So the key insight is that the world is full of patterns, right? Like patterns in data, patterns in language, patterns in images. And if you have enough data, and enough computing power also, you can build statistical models that recognize those patterns incredibly well. So machine learning had been around for decades, really. But it really took off in the 2000s for two reasons, actually. So one, we suddenly had massive, and I mean massive amounts of data, right? So, we had the internet, smartphones, social media. We were generating more data than like ever before. And number two, computers, so computers got fast enough and cheap enough to process all of that data, right? So then in 2012, something happened that changed the entire field. There was this competition called ImageNet where AI systems compete to identify objects in images. And a team used something called a deep neural network. Basically, it's basically like a machine learning system loosely inspired by how neurons in the human brain connect, if that makes sense. And they crushed it. I mean, the competition wasn't even close, right? Their system was so much better than everything else that the entire field, it seems like it just shifted overnight. Like everyone started working on deep learning, which you've probably, heard that term before somewhere, deep learning. Once again, like here's what's philosophically fascinating. We stopped trying to understand intelligence and started to simulate it statistically, right? So these deep learning systems work, right? They work incredibly well, but we often can't explain why. They're sort of like black boxes. You'll see this term used a lot in AI coverage. Like they're black boxes. They find patterns we can't see and make connections we don't understand. So we've gone from essentially intelligence is following rules we can't write down to intelligence is finding patterns in data that we can't necessarily articulate, right? And that's not just like a technical change. I think that's a fundamental shift in what we think intelligence is, if that makes sense. Okay, so that brings us to today, to now, to ChatGPT, to generative AI, to this moment, essentially, where everything feels like it's changing at once. And here's what you need to understand. ChatGPT didn't invent AI. I know it's obvious, right? I know all the technical folks are like, duh, Shay. But, I'm speaking to a general audience, right? It didn't invent AI. It didn't even invent the core technology it uses, right? So transformers, like attention mechanisms, large language models, that had been around for years, right? So GPT-3 came out in 2020, I believe. And the research goes back even further than that, right? But I know what you're asking. I know what you're thinking. Shay, why does this feel so different? Why does this feel like a new moment? A few reasons, right? So one, the interface. ChatGPT is extremely easy to use. You just type and it answers. You don't need to be a programmer. Really, anyone can use it, which means anyone can experience what AI can actually do, right? Number two, it's generative. So sometimes you'll even see a lot of us use Gen AI as like the short form of generative AI. Previous AI systems, mostly for the most part, classified things, right? So is this email spam? Yes or no? What's in this image? Identify it. But these systems, these generative AI systems, they create, right? They write essays, poems, code. They don't just analyze our world. They produce new content in it. Like, that feels fundamentally different. So I hear you. And number 3, and I think this is actually the big one. It uses language, not just to communicate, but as its entire operating system, right? It's been trained on vast, and I mean vast, vast amounts of human text. And it's learned the statistical patterns of how we as humans use language. So it can mimic our writing styles, our reasoning patterns, our ways of explaining things. And this actually brings us back to Turing and something I explored in my episode on the appearance of intelligence. So let's go back. So remember the Turing test. So the whole idea was, if a machine can perform intelligence convincingly enough, does it matter what's actually happening inside? With large language models, we're living that question, right? So these systems are really good at performing intelligence, giving the illusion of intelligence. You know, they pass Turing tests constantly, but are they actually thinking? Are they conscious? Do they understand what they're saying? We don't know. You know, we might not ever know for sure, right? But here's the thing. I think in the long run, we have to ask ourselves, will that matter? You know, because what matters is the appearance. What matters is how we interact with systems that seem intelligent, that seem to understand us. You know, like we have to look at these reports from these major AI companies where they study how users are interacting with their systems. It's mostly for companionship. You know, it's mostly for talking and engaging, right? So that's why I say it's so important how it seems these systems are interacting with us. Because ultimately that changes our relationship to knowledge, to work, to thinking itself, right? We're not just in a new technological era. You know, I think we're in a new epistemic era. For most of human history, language was how we represented reality. It's how we shared knowledge about a world that existed independently of our words. But now we have systems that generate language, that create text and arguments and explanations without necessarily having any connection to reality beyond, like, you know, patterns in their training data. It's language that doesn't represent, right? It generates. And in many ways, it can generate new and alternative realities for its users, right? And that's, you know, I don't want to go down a whole nother rabbit hole because I could talk for hours about that because it's a very important topic. But I think at the end of the day, people are using it to make decisions, to learn things, to understand our world. And that's not just a tool. You know, I say that, you know, constantly. I truly believe this is becoming critical infrastructure, right? That's something closer to what I'd call like an emerging electronic species, you know, because a tool, you know, you put it up, you pick it up, you put it down, you know, you can detach from it, but it's becoming the invisible layer that is basically animating our relationships and our world and our environments, right? And any system that can act autonomously in the world is obviously more than a tool, you know, because it shapes how we think and work and communicate. And yeah, it's basically a new electronic species, essentially. Okay, so where does this leave us? We've been building AI for 75 years. I said we, you know, like the actual AI researchers for about 75 years. And every generation, and I mean, really has reinvented what intelligence means. You know, first it was logical reasoning, then expert knowledge, then pattern recognition. Now it's generative language. And every time we've built it essentially in our own image. You know, we've taken whatever we think makes us intelligent and tried to replicate that. And every time we've discovered that intelligence is more than we thought it was. It's more complicated. It's more contextual. I mean, it's more mysterious, right? So when people ask the question, what is AI? There's no simple answer, because AI has always been a moving target. It's always been a mirror we hold up to ourselves, reflecting back whatever we think intelligence is in this particular moment. But here's what we know. AI is not going away. I mean, look, we're not going back to a world without these systems. It is quite clear that enough people, I mean, companies really, and organizations and institutions find it to be necessary. And it's becoming too powerful and too embedded in how we work and learn and communicate for it to just go away overnight, right? I think the question isn't, should we build AI? We already did, right? That's a closed question. It's been happening for decades. I think the question really is, what kind of intelligence do we want to amplify, right? What kind of thinking do we want to encourage, right? What kind of future do we want to create? Because AI doesn't replace human intelligence. I argue it amplifies it, right? Good thinking becomes better thinking. Good input, for the most part, good output, right? And bad thinking becomes worse. Laziness becomes amplified laziness. Rigor becomes amplified rigor, right? So if we want AI that makes the world better, we have to ask ourselves, what are we inputting to these systems, And obviously, there's the systemic questions as well about how these systems are being built. I don't want to, negate that in any way. But overall, what I'm getting at is we need to think clearly, reason carefully, and ask good questions. We need to understand not just how these systems work, but why we're building them and who they're ultimately going to serve. And, look, this is part of the reason why I do this podcast, right? That's why, critical thinking isn't optional anymore. It's critical. It's absolutely necessary, because we're not just building artificial intelligence. We're shaping what intelligence means for us and for the systems we create. And yeah, that story is just beginning. And we need your help to write it. Don't sit this one out. If this was helpful, please follow and subscribe wherever you're listening, and comment below, what questions do you have about AI? I know this history episode was long awaited. Let me know what I should make a podcast episode on next. I read all of your comments, and I have a full reading list on my Substack, which is in the description box below, including Jill Lepore's amazing book, If Then, which I believe is essential for understanding both the political and social history of predictive technology. Thank you for listening, and keep thinking critically.